Okay, let's talk about some cost estimating techniques. So I want to present various methods for estimating. And I want to do this with respect to important factors in an engineering economics study. So why is this important to us? Well, one reason it's important is if we want to estimate future cash flows and to investigate feasible alternatives. So one difficult part is estimating things like cost or revenues, useful lives, of perhaps equipment or other objects, residual values, salvage value, and so on. And residual values and salvage values are pretty close to the same thing. And what uses might we have for these ideas? Well, when we're setting selling prices, when we're doing quoting or bidding, or evaluating contracts, or if we're trying to determine if a proposed product can be made and distributed at a profit. Maybe we might be evaluating how much capital can be justified for changes and improvements, or as another idea, setting benchmarks for productivity improvements. So let's look at a simple cost estimation. Let's discuss the cost of getting a bachelor's of science. We can do this with what the book calls a top-down approach. And say we break our annual expenses down as so. You take our published cost of attending college annually, so say the first year, and then we multiply it by a factor associated with inflation, and we come up with a number, say $16,695 for the first year. We tack on some expenses that we might incur, and we'll just assume these are constant. Now we could attach inflation to these too, but just for simplicity, let's just make them all constant. And when we sum up the $16,695 with $6,000, we end up with $22,695 for the first year. And then, of course, we do the same for year 2, year 3, and year 4. Of course, increasing our estimate as we go. And our total cost then comes out to be $97,000.36. So just to label some of this material again, the inflation is represented by the multiplication of 1.06, so 6% annual inflation. And of course, the first number is the published cost to attend college. Another approach might be to use a bottoms-up approach. Here we break down the cost of 4 years attending school from the bottom and work our way up per year. For example, let's focus on one of these costs, say books. We might then come up with an estimate for the average cost of books per year. And we could do that by deciding that books are $200 per book. So we'll do a dimensional analysis here. We'll look at one book per course. And say 5 courses per semester, 2 semesters per year. We see, we can cancel our units here. We've got books going away. We've got courses going away. We've got semesters going away. So we get dollars per year now coming out. And we do this estimate and we get $2,000 per year. So that goes in for our first year. Now we can do, so as you can see, you have to do this calculation every year. And something like this is best done in a program like, say, Excel. So this is broken down. Per year. And then you can add up the total cost that you get for your tuition. Let's now talk about a common approach used in estimating engineering projects, an integrated cost estimate approach. We can break this approach down into 3 main categories, which we will call A, B, and C for short in the future. Work breakdown structure is the WBS. Let's put that up here. Usually shortened to WBS. And here we're going to explicitly define the work elements of a project. Things like maybe site work, or going to even more detailed framing or siding, and so on and so forth. Then we have cost and revenue structure. So working on delineations of costs and revenue made that we're going to need to use for estimates of cash flows at each of these levels in our project. And then there's estimating techniques. Some of those might be company specific or industry type techniques. But for example, you might have a specific technique you use to estimate the amount of concrete you need to pour foundations. So here's a flow chart to help develop cash flows. And we can think of things left of this dotted line, describe project and work breakdown structure. So we're setting up a work breakdown here. This is A, and then we're going to define our cash flow perspective and estimate baseline, determine our period of study when this is going to occur, and figure out cost and revenue categories and elements. So these sorts of things will fall under part B that we described above. And then our estimation techniques, and this is often an iterative process, and that's why it's looping here. This is C, where we use our determine the when to use the estimates and the models to use, and to develop cash flow alternatives. So maybe we're still focusing on our concrete pour. Well, we would have possibly a number of different alternatives for that. Maybe types of concrete that we're going to use, methods of the amount of rebar that we would use reinforcement bars that we would use depending on the type of concrete, and the vendor for the concrete who we're going to choose. That would change the cost, and we would compare those alternatives. Here is a work breakdown structure, and in this we go into increasing detail as we move down. And each of these boxes is a work element. So this represents block A that we talked about up above. Now let's look at a more detailed representation of a work breakdown structure. Here we can see a commercial building project set up in this. There are various levels here that, as you move down, or up in number actually here, but as you move down in the tree, you get more and more detail. These are, of course, the various work elements at different levels of detail. And this serves as just an organizational framework. You might have individuals in charge of each of these elements, and that's a good way to set up your organization. So when we talk cost and revenue in block B here, the ideas we want to concern ourselves with, these are often to some extent easy to be calculated. Like, for example, you've got capital, investment, labor. Now, labor might involve some estimation, material. Sometimes you can make non-estimated material cost, maintenance, taxes. So most of these are costs and not revenue. Insurance, most of these ideas I'm putting down here. Overhead, disposal. But you could have sales occurring, which is a revenue. You could have salvage value, which is a revenue, usually considered a revenue. And the issue could come up if you overlook something, especially if it's something costly. That can really put a damper on your project. And let's talk a little bit about block C estimating techniques. So these are used with pertinent cost and revenue details. So in the planning or initial evaluation stage, you might have an order of magnitude, which is plus or minus 30% of the correct value. You'll get a semi-detailed analysis in maybe a preliminary design stage, which might be plus or minus 15%. But when you get to an engineering or construction stage, you're going to want to have the most detailed analysis. And there's a cost associated with each of these. So if we set up a little plot of estimate accuracy versus the cost of making such estimates in time, I'm going to flip this curve and plot it the other way. But here we see the levels are much cheaper in level 1 or 2 of your WBS. And when you're in the more detailed portions, the cost are much less of a percentage of the cost of your project. But as you get more detailed here towards the 3 to 5 or 3 to 4 level of your WBS, you want more accurate cost estimates, and it's going to take longer to produce those cost you more to get people to actually produce those too.